So consider this given problem statement. So it says that if log of x base 2 plus log of x base 4 plus log of x base 16, and this goes continuously, this is taken as y, and this is the next equation that is given as. So if you observe the numerator, we have 5 plus 9 plus 13 and so on all the way up to 4y plus 1. The next one, we have 1 plus 3 plus 5 plus and so on all the way up to 2y minus 1. This is equal to 4 times log of x base 4. So in that case, we need to compute this particular expression, that is x squared and taken cube root on top of this plus y. Whatever is this expression, we need to apply the ceiling function on top of it, right? So the ceiling function, whatever output that will generate, that will be the answer for this given problem statement. Now let us proceed towards the solution. Now this is the given equation, and if you observe this given equation clearly, so this can be written as 2 to the power 1, 4 can be written as 2 power 2, that is 4, and 16 can be written as 2 power 4, right? Now a property of logarithm which I will be using here, that is log of base, let's say base is b power q, and in the argument I have a power p. So the property says that whatever power p is there, this can be written here and this q can be written here, and this will be log of a and base b. So this is the property which I am going to leverage here, right? Now, so this one can be written as the power of x is 1 and the power of base, that is 2, is also 1. That's done. Now the next one, the power of x is 1 and the power of this 2 is 2. So this becomes log x base 2 again. Similarly here as well, 1 over 4 and the base would be 2 over here, right? Now we can clearly observe one thing. In this equation, that is in the left hand side of the expression, log x base 2 is the common factor here, right? Log x base 2 is the common factor, right? So let me eliminate this part, and now clearly you can observe that this is a geometric series, right? Infinite geometric series. Now we need to compute the sum of this. So we know, so I'll be using this. So in the next step, I can clearly write here that first term over 1 minus common ratio. Now on resolving this, I'll be getting, that is 2 times log base 2 of x, that is equal to y. Now this is the first equation that I have resolved. Now I'll go for the resolution of the next one. So let me just consider the format over here and consider this given equation, right? So you can observe that this is arithmetic progression on the numerator, that is with a common difference of 4. So I'll replicate this one as it is, and the sum of this term would be y over 2 times 2a, that is 2 times 5 plus y minus 1 times common difference, that is 4. Similarly, in the denominator as well, this would be y over 2, the first term is 1, and y minus 1, the common difference is 2, right? And this 4 can be written as 4 over, and this 4 here can be written as 2 squared, right? And here 4 as it is. So in the next step, I'll be resolving this one as well. So just go to the next step. On resolving this one, this becomes y, that is 3 plus 2y over, this will be y, right? And this would be 4 over 2, right? Because this becomes log base 2, ultimately 2 power 1. So 4 over 2 is nothing but 2. Now this 2 times log x base 2 is something that we know already, right? So since this 2 times log x base 2 is already equal to y, that is, I'll write here because, right, since this is the situation, so here I'll replace this one by 2 times log x base 2 as y. Now on resolving this, this is a quadratic equation clearly. Y square minus 2y minus 3 is equal to 0, and from this we can write, that is y minus 3 times y minus y plus 1, that is equal to 0. So for y you can observe here clearly that y will be equal to 3, and here y equal to minus 1 is rejected. This one is rejected, right? So it is clearly obvious, right? That is, you cannot substitute any value for x. Upon the value substitution for x, this would give a negative quantity. That is not possible, right? So therefore this negative one is rejected here. So ultimately my y is equal to 3. So now let us observe the situation that when my y is equal to 3, so that means we can say that y is this, that is value of y I'll take and substitute here, and that is equal to 3, and from this we can write x will be equal to 2 to the power 3 over 2, 2 to the power 3 over 2. So this would be the value of x. Now coming to the expression, so I'll take this expression and resolve this one now. So now here I can say that this is the given expression. So instead of x I'll plug in this value. Instead of x I'll just plug in this value, and value of y, and definitely y will be equal to 3. Definitely in this case you can clearly observe that y is equal to 3 because the value of y I have taken 3 here. So this y I'll replace it by 3. Now you can observe here, so this 3 over 2 and this 2, so this 2 and this 2 will get cancelled out, right? And this 3 on the power of 2, and this is 1/3. So on cancellation of this is effectively 2 actually, right? So finally the ceiling, if I just take the ceiling function, so this one effectively resolves to 2, this one resolves to 2, and 2 plus 3, and ceiling of 5 is 5 itself. So therefore 5 is the answer for this particular problem statement.